Hello, good evening and welcome everybody to the Sigma meeting for August 2021. Can't believe it's August already, I don't know about yourselves, eh? But anyway, here we are, and my name's Pete Sherman. I'm the chairman of Sigma and I will be your MC for the evening. I'd like to start by welcoming not just the Sigma members that are joining us tonight, but also all our affiliated members as well from the other clubs around, from Has, Aberdeen, Caithness and Cairngorm, North Ronaldsea. And I'd like to welcome any first-time visitors as well that may be here tonight. You're more than welcome. And I hope you enjoy the evening. Helping me in the background, it should be Rich, but he's having trouble getting in. There has been an update to Zoom, I've just found out, so it may be a case that some of you may have trouble getting in tonight, but don't panic, it is being recorded and it will be on YouTube and you'll be able to catch up later if you've had any issues at all. So Rich should be here, but he's not in at the moment. But I've got Mick here with me as well. He's the Zoom co-host, so if anything happens to me, he will jump in and take over. And he'll be on his own for a while until I get back in. So if all goes well, you won't see them too much in the first half, unless something really technically, some real technical issue happens to me. Okay. I'm gonna put a bit of light on, keep forgetting to do that. Also tonight we have Stuart Brooks, who in the second half will be giving us the space news, and then after that Mick will be giving us a rundown of the Perseid meteor shower, and then after that we will have a little bit of club news from myself, and then we'll end around about 9:30, something like that, and then we'll go over to the gathering, but I'll tell you about that in a moment. Also, sorry, I meant to say also tonight we've got Chris, who's going to be handling the Q&As tonight, the questions that you're going to put in. If you've got any questions at all, just pop them into the Q&A at any time throughout the talks. The Q&A can be found in the Zoom toolbar at the bottom there. Just says Q&A, click that, put your question in and press send. And then, as I say, Chris will keep an eye on that throughout the evening and ask the questions over to David and Stuart if you've got any for Stuart in the second half. Okay. Do not go putting your questions in the chat if you can help it, please. As I say, the chat can run very, very, very quickly. And what can happen there is that the questions can get lost and they won't get asked. Okay. You may also notice that we've got the closed captions on as well. So it's called live transcript on here. Now, if that's a bit annoying for you, you can turn them off. Okay, just go to the live transcript button once again in your toolbar, click that and you can turn it off. All right. Okay then, and the other thing we've got is the chat. You can open up the chat and have a chat with everybody that's in the room and say hi to everybody as though you're sat next to them in the hall. We can all pretend, can't we? The chat will get turned off during the talks because it can be a little bit sort of off-putting for the speakers when they keep getting pop-up balloons coming at the bottom. All right. So don't forget, any questions you got, pop them into the Q&A at any time. All right, you haven't got to remember them to the end. As I say, we'll have the members gathering again at the end of this meeting. As I say, what happens there is the link will go into the Zoom chat. All you've got to do then is to click that link. It'll take you over to a waiting room until we close this meeting down, and then we'll let you into the other one. It's a chance for us all to get together and have a bit of a blather. Okie dokie. So the way the meeting runs, for those of you who haven't been here before, I think we've got 29 people here at the minute, so I think we might have a couple of new people. It's going up to 30. What we have is the main talk by our speaker tonight, David Paterson. We'll then go for a 10-minute break. We still keep the break in. It's a bit of a chance for get the chat open again, and we can all have a natter there in the chat, albeit by typing the chat. After the break, normally members' photos, but we haven't had any sent in this month, so that won't be happening. So then we'll have Stuart Brooks with the space news. Mick will be doing a bit of the Morning Sky at night. Won't be great deals. It's still not that dark, but he will be covering the Perseid meteor shower that's happening on the 12th. And then there'll be a bit of club news from myself, and that will be me, and that will be us finishing around about 9:30 on here. Around about then. We're not a stickler for time here. Okay, anyway, I would like to welcome our guest speaker tonight. And to say, tonight we'll be taking a look at the art of navigation and astronomy with David Paterson, who joins us tonight from Dundee. You're in, aren't you, David, I believe?
A little bit outside Dundee.
Outside Dundee, yeah.
Right. Will I pop up the title screen?
You can put the title screen up. As I say, since the earliest times, astronomy has played a big role in sort of navigating the globe. And David will tell us about these times when he had relatively simple methods. And he'll be looking right up the latest techniques which rely on the theory of astrophysics, I believe. David has had an interest in astronomy since he was a boy, I think, like many of us here tonight, or girl, do apologise, I must get that in. He is currently the secretary of the Dundee Astronomy Society and has been for quite a few years, I believe. Not surprisingly, coming from Dundee, he also has quite an interest in sailing. And when I say sailing, I don't just mean these small sailing boats. Did anyone watch the Olympics on the sailing? Those little tea trays with the beach towel on them. That was amazing. That was better than Formula One. But David he does proper, sort of hornblower style sailing with the tall ships as well. But I won't steal his thunder on that, because I'm sure he's going to tell us a little bit about this during his talk. So everyone, would you please welcome David Paterson with his talk on navigation and astronomy. Over to you, David.
Thank you very much. And thank you for that, Pete, for that nice introduction. As you say, I've been interested in astronomy for many years, and as well as being interested just in astronomy and observing and doing some photography, I've also got a strong interest in the history of astronomy and the history of science in general. And then, as you say, a few years ago, I got interested in sailing. I came to it very late in life, you might say. But I jumped in with both feet to the world of tall ship sailing, and I was lucky enough to choose as my first and still pretty much my favourite ship, the lovely Dutch three-masted bark Europa. And the Dutch are very proud of their seafaring traditions, and the crew on board are more than happy to teach you any of the old nautical skills like rope work, sailmaking, carpentry, and of course celestial navigation, which they'll give you the basics of and teach you how to use a sextant to take sights and so on. Now, to go back into the history of navigation, which of course, being interested in the history of science, I wanted to find out more about. If we go back a few thousand years, we find that mankind has always had an urge to travel, to explore, to colonize new places and to trade with their neighbors wherever they go. And in sort of late Neolithic, early Bronze Age times, we find examples like this, which is a log boat, which was found in the mud on the banks of the River Tay, about 4 miles from my house, in fact. It's a decent size canoe. It's about 9 meters long, so it could have carried a fair amount of cargo or people up and down the River Tay. And in those days, rivers, waterways, and going around the coast a little bit was pretty much the extent of navigation. This boat wouldn't really be suitable for open ocean. You couldn't go out into the North Sea in it, for example. But people did travel about a great deal, and as time moved on, of course, it was desirable to trade further and further afield. And to find the origins of true celestial navigation, we go back to the civilizations that grew up in the Eastern Mediterranean in the mid-Bronze Age. And possibly the first example of a real seafaring and trading nation was the Minoans, based in Crete. Looking at the wrong card there. The Minoans flourished from about 3500 BC to 1450 BC And they traded all over the Eastern Mediterranean and even went, as you can see, as far as Spain in the west to get copper and tin, which are the ingredients of bronze. Sorry, a little bit lost my place there. The typical Minoan ship was a fairly reliable boat, a lot bigger than the log boat we saw. Would carry a fair amount of cargo and crew and could trade easily around the Mediterranean. And we can see that they made fairly long voyages, which would have taken several days to cross some of those stretches of water and would have been out of sight of land for quite a considerable time. Even at sea, when you're at sea, even from a high vantage point, if you climbed the mast on a ship like that, your horizon would still only be a few miles or a few kilometers away. So they needed some reliable way to navigate. Now, there's very little actual physical evidence from Minoan times of navigation techniques, but from the archaeological evidence we have and some of the writings about the Minoans from later, we know that they did use the stars around the celestial pole, the polar region, and also the sun. The sun would rise towards the east, be at its highest point when it was due south, and then would set towards the west. So being able to determine roughly the points of the compass would allow for fairly basic navigation. And certainly within the confines of the Mediterranean, you can't really get too much lost. Now, as astronomers, of course, we all know how to find the pole star, the North Star. We can use the pointers in the Big Dipper or plough of Ursa Minor and follow the line that extends from there to the pole star. And it's a very good indication of where north is. If you take a time-lapse image of the sky, you find that the pole star Polaris is very close. It's less than a degree away from the true celestial pole. So very reliable for finding the north. The thing is, in Minoan times, about 2000 BC, 3000 BC, Polaris wasn't our pole star. The Earth's axis spins around, rotates, as we say, precesses like a spinning top. And oops, in the time of the Minoans, it was a star in the constellation of Draco called Thuban, which was the pole star. And it was actually much closer to the celestial pole than we have today. And in 2000 years' time, the precession will have carried the celestial pole around, so it's close to Gamma Cepheus, or Eri as it's known. Now, one useful thing you can do is to measure the angle of the pole star above the horizon or above horizontal. And although we don't have any instruments from Minoan times, it's very easy to make an approximation of angle using your outstretched arm and hand. It varies a bit, obviously, because hands and arms are different sizes. But it is a pretty decent approximation. And what you can find is that if you measure the angle of the pole star above your horizon, if you can find a flat sea level horizon or a good flat area, you should find that the angle of the pole star above the horizon is equal to your latitude on a map. And this is a very useful navigational tool. And I should add that observations that the angle of the pole star or the celestial pole varying with latitude consistently, and the fact that new stars appear as you move further and further south, new stars come up over the horizon, gave these early navigators and the astronomers and priests of that time the clue that the Earth wasn't in fact flat, but was curved and probably spherical. The notion that sailors in the time of Magellan or Columbus thought that the Earth was flat and would fall off the edge is actually a bit of a misconception, which was popularized in the 18th and 19th centuries. So the Minoans, they flourished for a few thousand years in the Mediterranean, did very well, and then suddenly around 1450 BC, they disappeared. And The most likely cause is the volcano Thera, or Santorini as it's now known, which exploded at that time and would have caused huge tidal waves that would likely have swamped the coastal communities. On Crete, the ash cloud would have blanketed fields, and it's likely that either the Minoans suffered a complete collapse and were wiped out, or what's more likely is it made them much more vulnerable to invasion by neighboring cultures like the Mycenaeans in southern Greece, who were quite warlike at that time and would easily have gone in and invaded the Minoan culture and civilization and taken it over. So with the Minoans gone, there was a big gap in the opportunities for trade and travel around the Mediterranean, and they were fairly quickly replaced by the Phoenicians and the Greeks. Phoenicians, of course, are legendary sailors, and we can see from the map here that as well as the Mediterranean, they also went up into the Black Sea, round into the Atlantic and up the coast of Europe to southern Britain, where they traded for tin, which was quite well developed tin mining in southern England at that time. There's also information or evidence that the Phoenicians traveled round the coast of Africa out of the Mediterranean and down the west coast of Africa as far as Gabon. And there is tales, there is writing and some circumstantial evidence that around 600 BC, the Egyptian pharaoh Necho chartered a Phoenician fleet to sail from Egypt down through the Persian Gulf, round the south of Africa, to test whether in fact Africa was a separate continent, didn't have anything attached to it. And after about 3 years, they reappeared back into the Mediterranean, sailed back to Egypt. One piece of evidence that kind of confirms this is the tale that when they were sailing west on the south of Africa, the sun was on the right-hand side, which was completely unheard of for anybody in the Mediterranean north of the equator. The sun could never be on your right as you were sailing west. So they were certainly major traders and explorers. Again, we don't have a huge amount of information about their navigation techniques. We have a reconstruction of a Phoenician ship, which we can see is a bit bigger than the Minoan one, much sturdier, would carry a bit more cargo, and certainly capable of sailing out into the Atlantic up to Britain or down around Africa. Now, again, as I say, we don't have a huge amount of information about their navigation, but we know that they did use the stars and the sun and moon, and the Greeks called the constellation of Ursa Minor Phoenici, which was the Greek name for it at that time, implying that it was of importance to the Phoenicians. And there's a passage in Homer's Odyssey where Calypso tells Odysseus to keep the bear on his left and watch the position of the Pleiades and Orion as he sails east from our island. So sailing towards Orion rising with the little bear on your left would keep you sailing east. Now, I mentioned that knowing the height of the pole star above the horizon gives you your latitude, which leads to a very easy navigational technique, which we're fairly sure was in use at these times, which is that if you know the latitude of your destination, or the angle that the pole star would be above the horizon at your destination, what you can do is you can sail roughly north or south as appropriate till you reach that latitude, measuring the angle as you go. And then once you get there, you just sail directly east or west, staying on that line as much as you can, and you should get to your destination or arrive very close to it. Now, as I say, we haven't got any evidence for any navigational instruments from the time of the Phoenicians or the Greeks in this era, but by about the turn of the millennium, coming into 0 AD and the first couple of centuries, instruments started to appear, and one of the earliest is called a kamal. And this is basically a rectangular board with a hole in the middle and a string with knots in it. And each of these knots represents a different destination, a different port that that ship might want to go to. In operation, the navigator on the ship would hold the knot that designated the destination they wanted to go to between his teeth and stretch out the string. And then the board would be exactly the size of the gap between the horizon and the celestial pole or the pole star. So that would allow them to sail consistently on a latitude, or sail to a latitude and then sail down the latitude to their destination. So as we move into the modern era, you might say AD, and another group of explorers, adventurers, and traders were also making their mark. And I think the Vikings may have had a worse press than they deserve, really. I'm certain they did do a bit of conquering and plundering and pillaging, but at the same time, they were also great explorers, travelers, and traders. And they went all over Europe, through the Mediterranean, Black Sea, and of course, their legendary journeys to Iceland, Greenland, and to the Americas. Being kind of a separate culture entirely from the Mediterranean side of things, they developed their own unique and unusual navigational instruments. One of these is called the Viking sundial. And this fragment of it was found actually in East Greenland. And in use, it seems to have been used by casting the sun's shadow on a line scribed on the instrument. And from adjusting possibly angles according to the date, approximate date, it would be possible to sail on a consistent latitude using this. And the latitude line that's on the piece that we have approximates to 61 degrees north, which interestingly takes you from the west of Norway, just past the tip of the Shetlands, a very strong Viking community, Faroe Islands, and then on to the East Greenland coast, roughly where the, not far from where that artifact was in fact found. Now there's another legendary Viking instrument, which for many years was thought to be a myth, but in fact, after a few finds in Viking graves, the sunstone turns out to be a crystal of Icelandic spar, and I would love to get hold of a piece of crystal like this. One of the problems of sailing in northern latitudes is that the skies are very often overcast, completely clouded out, and you can't see anything. But with this, the polarized light coming from the sun through clouds creates two bright spots in the crystal, and by rotating the crystal until the two spots are equal brightness, it's possible to determine exactly where the sun is, even when it's completely cloudy. So by measuring until the sun is at its highest point, you then know which direction is south, and that'll help you steer on whichever course it is you want to go. Now moving on a bit again, the other instrument that you'll find on every boat is a compass. Now, compass first came into use in China and the Far East about the 1st century AD, but it didn't arrive in the West until well over 1,000 years later. It's in China was a 50-50 choice, and they chose to have things pointing south rather than the convention that we do of having it pointing north. And these two are a magnetic spoon, as they call it, which will rotate on a polished metal plate, and a rather nice little floating fish made of some iron alloy or iron, which would point south. The compass can't tell you your exact position on you can't tell your position on the Earth, but it can help you steer consistently on a straight course in whichever direction you want to be going. And the early Western compasses, of course, based on it, are just as usable today. You can find hill walking compasses that look almost the same as these. And the technology, of course, hasn't changed much. It's basically just a magnetized needle. And the astronomical connection, of course, to compasses is the Earth's magnetic field, which is created by the magnetism within the core, the iron core and the liquid metal around it. And we're only now really beginning to understand the mechanisms by which the currents in the magnetic field are created within our core. And it leads to questions about how the Earth came to have this and what the formation of the solar system was like. And we were lucky enough, I dare say, that Earth formed where there was an abundance of rocky and metallic material to come together to make a metallic core and a nice rocky crust. And for the planet to be big enough that it didn't cool down and that we still have a liquid core which can rotate and create the magnetic field. Mars, for example, is basically the same material, but it cooled down too quickly and lost its magnetic field because it's so much smaller. And if there were ever any ancient Martian civilizations, as we read about in so many science fiction tales, the ancient civilizations on Mars would not have been able to use magnetic compasses to navigate. So I've already mentioned how useful measuring angles are, and one of the early instruments that was developed for measuring angles of things in the heavens was the astronomical astrolabe. It can measure lots and lots of different things, the angles between stars, the height of objects above the horizon, and give you lots and lots of readings. And it's an incredibly complex instrument. It was developed initially about the first couple of centuries AD, and by the end of the first millennium, these beautiful instruments were in wide use by astronomers and so on, and astrologers, of course. Using something like this on a ship would be very difficult, however, because it's so complex and difficult to manage. So in about the 13th century, a much simplified version known as the mariner's astrolabe was developed, which has only one purpose really, and that is to observe some object in the heavens and measure its angle above the horizon. In use, the astrolabe hangs by gravity to keep it vertical, and you sight along the axis to find the object that you're looking at and read off on the scale. And there are still quite a lot of people today who make reconstructions of these instruments and use them to try them out to see if they can navigate in the old-fashioned way, so to speak. And they can be quite successful. An alternative to the astrolabe was the mariner's quadrant. Again, it's simply a protractor-like device with a plumb bob to measure off the angle. And as with the astrolabe, it does suffer from the problems of trying to get measurements on a ship which is pitching and rolling. And in particular with this, if the wind is blowing as well, then the plumb bob's going to move about. But they'll give you reasonable readings, and it should be possible to get decent angles. However, a little bit later, a better instrument came into use, and this is the cross staff, or Jacob's staff as it's called. This was produced in about the 14th century, and it consists of the staff part, which is a piece of wood with markings on it, and the transom, which can slide up and down on the staff. And in fact, there would be 2 or 3 different size transoms depending on the readings, the measurements that you wanted to make. And in use, it's quite simple to hold it steady and adjust your transom until the 2 ends tips of the transom match the horizon and the object that you want to measure the angle to. So as the techniques and technology, the instruments developed, so too did the mathematics and the science of navigation. Now we've seen that you can measure your latitude using the pole star or Polaris. That's only at night if it's a clear sky, but you could also use the sun during the day if you could accurately figure out where it should be. And the first real astronomical almanac for this was produced in 1473 by the mathematician and philosopher Abraham Zacuto. And these rules for the astrolabe allowed mariners to take a noon angle when the sun was at its highest point, and by checking against the date, they knew how high the sun would be from a given position, and then could determine their own latitude from that. And instruments were being improved as well. One of the drawbacks of things like the astrolabe, quadrant, or cross staff is that you have to look at the sun, which is painful and dangerous and very difficult to get a good sight on something like that. So in 1594, the English navigator John Davis introduced the backstaff, which meant that you could have the sun behind you shining over your shoulder, and that would avoid having to look directly into it. And in use, it was basically similar to the cross staff, but casting the shadow from one vein onto the horizon vein, which usually had a slot in it that you could sight the horizon through. And by reading off the two angles on the two quadrants, you could then work out the elevation angle of the sun at that point. So if we look at the age of discovery, the age of adventure, and into the age of sail, the typical navigator's toolbox, if you like, was instruments to measure angles, tables to help you use those instruments, compass to steer a course, and maps, which we could say are of dubious veracity or dubious accuracy. Now, nearly all of the techniques, the instruments and tables that we've looked at will help you measure your latitude, but that's only really half of the equation. The other thing you need to know is your longitude. Latitude is your position north or south of the equator, and longitude is your position east or west of a prime meridian, which is in Greenwich. The story of how Greenwich came to be the prime meridian is quite an interesting one that I won't go into, but involves lots of disputes, international disagreements, bits of wars, and well worth reading up on. The problem of longitude is essentially one of time. If the sun is at your local noon at its highest point, then for every degree east of Greenwich, it'll be 4 minutes earlier, and for every degree west of Greenwich, it'll be 4 minutes later. So if you had a clock that was keeping time in Greenwich, then you could compare the time it said local noon was to that Greenwich time, and that would tell you exactly your longitude. However, for clocks of the 17th, 18th century, they were not that accurate, and also the motion of a ship at sea, the rolling and pitching, would throw them off completely, and it was virtually impossible to actually accurately get a decent measurement of time. There were various other methods which were proposed to try and solve this problem. One quite interesting one is the lunar distance method. Using this, you're measuring the angular distance between the moon and a star, measuring their altitudes, and then by using tables and a lot of calculation, you should be able to get the local time at that point. However, measuring these accurately was quite difficult, and also the tables that were available or had been produced up to that point were not really accurate enough to get it precise. And progress was fairly slow in trying to solve the problem until in 1707, there was a major naval disaster. The British fleet were returning from Gibraltar and ran aground on the Scillies. A loss of over 1,500 men, and the Admiral, Sir Cloudesley Shovel, was rightly blamed for the disaster. He had overruled one of his sailors who'd done his own calculations and said they were too close to land. And in fact, he had him hanged for disputing navigation with his captain. And in the wake of this, the British government instituted the Board of Longitude in 1714 to try and solve the problem. When they offered a prize of what would be millions of pounds in today's currency to find a good solution. And there were quite a lot of ideas, including some seriously mad ones, but things like improving the lunar distance method. Another one was using the moons of Jupiter, which are pretty much like a clock going round in the heavens. And in particular, the eclipses of the moons by Jupiter's shadow are very precise timings. However, trying to measure these angles or observe these events from the deck of a ship in the middle of a sea is very, very difficult. And that never really worked out. I'm sure most of you know that the solution was eventually the development of an accurate clock, an accurate chronometer. John Harrison, a carpenter and clockmaker from Wakefield, spent 20 years of his life improving and improving and improving until he was happy with his H4 chronometer. And that was taken on a voyage from London to Barbados and had an error of only 39 seconds in that voyage. And the story of the development of chronometers and the longitude problem is another fascinating one that would take too long to go over. It involves lots of development, lots of science, and lots of skullduggery and fraud and so on, and particularly actions of the Astronomer Royal at that time, Neville Maskelyne, trying to prevent the award of the prize to John Harrison. So there's a book by Dava Sobel, which is called Longitude, which is well worth a read if you want more information on this, this particular part of the story. So now with longitude and latitude solved, the next step was to develop even better instruments. And probably the quintessential tool for celestial navigation nowadays is the sextant. This is a much lighter, easier to use instrument than anything that had gone before it. It's very accurate and reasonably easy to use even in fairly rough seas. It's what's called a doubly reflecting instrument in that it has two mirrors. It has a horizon mirror, which is semi-silvered, or sometimes it's just a half and half mirror, through which you can see out to the horizon. And it also has this index mirror, which is attached to the index arm. And by rotating it, you can move the reflection of a star or whatever other body, the sun, planets, down until it just touches the horizon, and then read off the angle on the scale. The sextant didn't start out as a sextant, it actually started as something called an octant. The first octant being an eighth of a circle, so that's 45 degrees, but because of the double reflection, the scale gives you a 2-to-1 reading, so it can measure up to 90 degrees, which would be from horizon to vertical, which would normally be okay for measuring altitudes. First ones were produced around the 1700s by Thomas Godfrey and John Hadley. And it turns out that in Isaac Newton's notes, which were discovered after his death, he had proposed a similar instrument as well. The sextant was developed at the request of Admiral John Campbell in about 1750s, because he was trying to improve the lunar distance method and needed to measure angles greater than 90 degrees. So the sextant can measure up to 120 degrees. And the first sextant was produced by John Bird, an instrument maker, in 1757. Modern sextants are lightweight. They're made of materials which don't suffer from too much from thermal expansion or contraction. They have shades to reduce the light coming from the sun so you can safely view it. They have horizon shades to cut down glare, and they have a drum vernier adjustment to let you get sub-degree accuracy on your readings. So a very sophisticated instrument now indeed. And I suppose, having talked about celestial navigation and measuring angles to things, I should maybe explain a bit how celestial navigation works, although this is kind of like a very simplified explanation. If we start with a star somewhere off in the universe, and you draw a straight line from that star through to the center of the Earth, then there will be a unique point on the Earth's surface where that straight line goes through, and that's called the geographical position of the star. Now, of course, that isn't stationary. Remember, as the Earth rotates, stars will rise, go across the sky and set, so it moves 1 degree every 4 minutes, but you can tell where that's going to be. Now, if you're out at sea and you happen to look straight up, vertically above you, there's a bright star, and you think, oh, that's interesting, and you have a very accurate clock on board, or a reasonably accurate clock, and you open up your almanac with all the details in it, and then you can look up and see where that star is, and a bit of calculation, you can find exactly where you are at that point. And this is typical pages from a nautical almanac. However, one of the problems you might have is that we use one set of stars for navigation, and to keep the almanac manageable, they've chosen 57, as we call the navigation stars. And these 57 stars are spread pretty much over the sky, so that no matter where you are on the planet, you should be able to see several of them. So if it's not one of those 57 stars, then you aren't going to be able to work out where you are. You know, the almanac also contains useful information about planets, the moon, sun, and other things to help with navigation. So if you're not directly under the star, and we can represent the starlight here as parallel lines because stars are so far away that the light is effectively parallel. What you can do is you can get your sextant and measure the angle from the horizon to the star. And that angle will allow you to measure, or allow you to calculate, the distance that your ship is from the GP, from the geographical position. And if you're a known distance, a constant distance from a point, then what you have is a very big circle, or sometimes a very big or sometimes small circle. But you're on a circle somewhere around the GP at a known radius. So you could plot that on a sphere, and if you know your latitude, which you can calculate from the celestial pole, you can get your position roughly. So what you could do is you could go to a map and draw the GP and draw your circle around it, and that doesn't tell you a great deal, but if you start taking more sites, you build up a number of circles and give you a point where you pretty much definitely are. There's a couple of problems here, is that, first of all, on a chart like this, the lines that you're drawing, even with a fairly fine point, are going to be tens or hundreds of miles wide. And also, this bigger problem is that this chart, or this map, is a projection of a sphere onto a plane, so it's very distorted. These would not be circles, they would be like egg-shaped ellipsoids, and it'd be impossible to draw them. However, the solution to this is that the charts that we normally use for navigation are on a completely different scale, and on this kind of scale, those circles, especially if they're very large, effectively become straight lines. And you can approximate that by drawing a tangent to the circle. And by going through the various calculations to reduce, as we call, reduce your sights, you can come up with the tangent lines to those circles. And by adding more and more of these tangent lines, you can identify your position fairly accurately. And on a good day, you can, in fact, get it down to within a few miles. Now, nowadays, of course, we're much more familiar with other forms of navigation. The ubiquitous GPS that we use to get from A to B. And we have GPS at sea also. It doesn't show us the road junctions, but it does show us the interesting things that we might need to take note of in the water. And GPS relies on a constellation of satellites which are orbiting the Earth, all of them on slightly different orbits, and there are 24 of them in the constellation. And it should be possible to see from anywhere on the surface of the planet at least 4, and in general you can see quite a lot more. The satellites, as they go around, send out little messages saying what their position in 3D space is and what the clock on board tells it the time is. And the receiver receives all these messages, and comparing the times to the receiver's internal clock, you can work out time, speed of light, distance, and then calculate your position from the positions of the satellites. However, there is a wrinkle, and rather than just a space flight, an astronomical or astrophysics connection. And we go back to one of the great minds of the 20th century, Albert Einstein, and his theories of relativity. And his first theory, special relativity, talks about objects in motion, objects in relative motion. And because the satellites are moving fairly fast, they're at an altitude of 20,000 kilometers and moving at a speed of about 14,000 kilometers an hour, their clocks slow down by 7 microseconds per day relative to the clocks on the ground. Einstein then developed another theory called general relativity, which talks about gravity and warping of space-time. And it shows that in lower gravitational fields, clocks run faster. And an altitude of 20,000 kilometers, the clock on the satellite runs faster by 45 microseconds per day. And if you add those together, 38 microseconds per day drift in the clock as it's going around compared to a clock on the ground. And that would mount up to an error of 11 kilometers per day every day. So the satellites are continually monitored by ground stations, and corrections are made to the satellites onboard clocks to make sure that they stay in sync with ground clock, if you like, or notional correct clock. And once you have your information from the satellite and these, it's very like we used with the sextant, in that if you know the positions of the satellites, you can draw circles, or since it's in 3D space, you can draw spheres around the 3 satellites here. And where those spheres intersect, you get your location. And of course, quite often you'll be able to see 10 or 12 satellites to give you a very accurate position. Now, you'd think with all this modern technology and GPS, we would have started to think that the days of navigating by the stars are over. And for many navies around the world, many merchant and military navies, they stopped teaching celestial navigation to their recruits. But then a few years ago, the Americans decided, well, they came to the realization, I should say, that the GPS system was vulnerable. It could be hacked. It could be knocked out of action by space-based weapons or satellite collisions or debris. So they reintroduced the teaching of celestial navigation to their recruits, and quite a number of other navies around the world followed suit. I'm glad to say that the British Royal and Merchant Navies have never stopped teaching celestial navigation. It's always been a part of the curriculum for deck officers in both branches. So there is still a future for celestial navigation, and there is something quite satisfying about taking sites, going through the calculations and working out and seeing how close your calculations come down to the little flickering numbers on the GPS in the wheelhouse. And it's a craft, an art that you can learn fairly easily. The calculations aren't too difficult. And there's something quite satisfying about doing this and feeling a connection back over those thousands of years, back to the old Minoan, Phoenician, Greek sailors in the Mediterranean at the very beginning of this journey. And if you ever fancy going on a sail training ship to do a little bit of learning, I would highly recommend, of course, Bark Europa, but there are a lot of other ones out there, and it's certainly an interesting skill to learn. So I hope I've given you a good idea of the history of celestial navigation as I've managed to research it. Purely Western navigation, I should say. There are other cultures which are still to look into. But if you have any questions, I'll do my best to answer them. Thank you very much.
Okay, David, thank you very much. That was absolutely fantastic, again, from yourself. I'm not seeing any questions coming in at the moment, but I've got myself that Viking Sunstone. Would that be like a high-value gem, or just or not?
I don't think it's very valuable. No, it's just a feldspar, so it's not really like a jewel or anything like that.
Right.
I think it's reasonably easy to find. It's just that finding a large enough crystal is quite difficult. I haven't managed to track one down, but it was thought to be a myth for a long time. But you know, a few archaeological finds, and suddenly it's a reality.
It's a reality. Yeah, it's something I never heard of, and it's quite an amazing way to do a bit of navigation. That really is. Do any of the panelists have any other questions at all? If you want to, just turn your microphone on and butt in.
There's no questions have come through to Q&A, but I'm standing by. But there was a message that came through to me from Mick. When you talked about John Harrison's chronometer, Mick O'Donnell has asked, how do they calculate the error of 39 seconds?
That I have never discovered. There must have been some way of doing it, possibly by measuring. I'm not really sure. No, I could guess, but I think that's something I will make a note actually to find out for the next time I do this.
Thank you very much. I know you said that the Navy are teaching sextant navigation. I know that the Air Force navigator training, certainly in the 80s and 90s, was still training it. But obviously now with the move towards GPS navigation and the fact that all airways traffic is done by GPS, I think that's now been phased out, which is slightly sad, really.
Slightly worrying as well, Chris, is like you said, if it suddenly goes down, what do you do?
Yes, so there is that is certainly a concern, and it has been discussed at extremely high level if there is any jamming. There is an alternative system to the one we use. I know the Russians have their own GPS system which they use, but I'm not sure if we're quite capable of jumping onto that. Just as an interesting aside, actually, when you mentioned Harrison's chronometer, it was a Harrison's chronometer that was auctioned for £6.2 million on the last episode of Only Fools and Horses.
Really? That certainly would be worth that.
There's one question coming, is it, Chris?
Yes, it's coming from Kevin. They did a return journey and halved the error. Quote this is coming for them.
Okay, thank you very much.
There we go. We've got a knowledge base here. And say, if anyone's got any more questions, feel free to pop them into the Q&A. But
I'll stop sharing the screen now.
Okay, that's fine.
Don't have to go back through any of the slides.
Oh no, hang on. There's something coming in, I think.
So Christine, thanks, has said the planetarium in Aberdeen College in North East Scotland was originally made for navigation.
Oh yeah, that's true. Yes, one of our ex-members, or I should say late members, Dave Gavin, who I'm sure many of you recall.
Know.
Yeah, Dave Gavin was quite a famous figure around Scottish astronomy. He was our honorary president for many years, and he taught navigation at Leith Nautical College. In fact, I have one of Dave's sextants here, which is a rather nice old instrument, which needs a bit of restoration work, and I'm currently preparing. This was left in his estate when he died to the Dundee Astronomical Society, so it's a
wonderful,
quite a nice little instrument.
Lovely little thing. One big thing. Yeah, great stuff.
Right. As an example also of another type, I have my own sextant, which is made of plastic. But being made of plastic doesn't make it any less accurate. Well, it is less accurate because it's a cheaper and less precision instrument, but still very useful.
A lot lighter to carry and
around the world
move
with
around.
these things.
So a lot lighter as well to carry around.
A lot cheaper as well.
That's the main point.
This is just a few £100s, whereas a good quality marine sextant will set you back well over 1,000.
Right.
It's sort of into the telescope range of prices for these kind of instruments.
Really good stuff. Okay, David, I'll say thank you very, very much for that. And say,
thank you.
You know, it is interesting how all the way through time astronomy has helped with navigation and other things as well, obviously.
Oh, yeah.
What we'd like to do, I know you may have one or two of these already, but I want to send you down a little crystal tumbler.
Oh, lovely.
Okay.
Yes,
now there's a ruling gone around for a few years that if you get 6, you can trade them in for the decanter.
All right. I think this is my 4th one.
Yeah, but we normally change the pattern sometimes, and they got to be matching, so you can't get that.
So change it every few years, so you can't do that. Yeah. I very much appreciate that. Thank you. Very nice.
Thank you so much for giving up your time. I know how much it takes to put these talks together, and I know it was only a day or two or so ago that you got it up together. To updated it, let's say, but
fiddling and making more adjustments.
Yeah, as we all do.
I do enjoy talking to people and talking about things like this, especially if it's to do with astronomy
and sailing, your 2 favorite hobbies.
Oh yeah, that's true.
I must admit, I've got a bit of a bug for it, so I hired a boat down the Caledonian Canal at the beginning of last month, middle of last month, and I've got a bit of a bug now, I think, but I'll see what I can do about that. So once again, thank you very much, David. So we'll go to the break now. Just before I go to the break, during the slides in the break, I'm going to throw up a slide about the next month's meeting, which is the GMFL, George Fraser Memorial Lecture. The links for this will be going around. It will be live on YouTube as well, and it's going to be part of the Orkney International Science Festival. What I would like you to do is, to say, it was in the newsletter. If anyone can think of anywhere to share the links, please share them, and we'll get as many people on to watch that as we can next month. We're using it as like a public, a public session. So we normally try and do at least 1 or 2 of them every year. So with that, we'll say go to the break now for 10 minutes. We can have a quick drink ourselves of something, and we'll see you back here. 25 past. It'll be about sort of 25 to something like that. Okay. So thanks again, and we'll see you in a while. Okay, everybody, welcome back to the second half of the show. We'll kick off now with, let's say, we normally have members' photos at this point, but no one sent any in, which isn't a real surprise because, as I say, sort of June, July, the sky is very, very light all night long, unless we're getting noctilucent clouds. But all we seem to be getting lately is normal clouds. There's some good days, but as I say, it's not surprising. As I say, sky is dark, it isn't dark, and people are on holiday and that sort of thing. So, but please do start sending your photos in once you start taking them again. As I say, the link for that is members' photos at sigma-astro.co.uk. Just send them in, and then we'll get them shown next month. Okay then, Stuart, if you're there, we'll hand over to you. I can't hear you, Stuart.
Right, I'm here now.
Now I can hear you now. Yep, over to you. Well done.
Okay, good evening, everyone. Space news for August. What I've done is gone through activities and events and some issues that occurred during July. Some you may well have already seen on the television, because it gets quite a lot of PR now, the space activities. And some of the dates and things I've actually got, or the dates that I recorded it, may well have changed. So you may find it's been updated to what I'm actually telling you. Okay, I've gone from SpaceX's Super Heavy booster down to 10 times more asteroids hit the Earth than previously thought. So I've gone through the list there. Okay, the SpaceX Super Heavy booster rocket. On the 1st of July, SpaceX's first true Super Heavy booster was rolled out of its high bay to a launch pad at SpaceX's Starbase site in South Texas. And at 230 foot tall, 70 meters, it is the first stage of SpaceX's fully reusable Starship transportation system, which the company is developing to help humanity colonize Mars, among other tasks. And that's it rolled out. You can see the size of it as it's being rolled out to its launching pad. On the 19th of July, SpaceX fired up the rocket for a short first of its kind test for the new launch system. The 3 Raptor engines were ignited in a brief static fire, as you see there. And that was successful, unlike some of its previous tests with its nose section. However, this particular Super Heavy, known as Booster 3, will not fly. It will undergo ground tests intended to pave the way for its successor to launch on the first orbital test flight, which could occur as early as this summer. Now, it's planned that it will use Booster 4 for this, and it will probably use 29 Raptor engines, but the future ones after that will use up to 32 Raptor engines. It'll take off from SpaceX's Starbase, and if all goes according to plan, it will splash down in the Gulf of Mexico and the South Texas coast, and the Starship element will go into Earth orbit and eventually come down in the Pacific. The Starship upper stage is the 165 foot tall, 50 meter spacecraft, a prototype which achieved a 6.2 mile high test flight in May after various unsuccessful attempts, which I think we've seen previously. This, the Super Heavy, is the core of the company's plans for its future missions to deep space. NASA has picked SpaceX Starship to land astronauts on the moon as part of the agency's Artemis program. And SpaceX has already sold another Starship flight around the moon to Japanese entrepreneur Yusaka Masawi. And SpaceX is looking for this to provide support to astronauts to Mars. So looking forward to see what happens in the next weeks or month in terms of the test flight of this of the booster. The European Space Agency announced on the 1st of July that the James Webb Space Telescope mission had passed a key launch review, keeping it on track to lift off atop an Ariane 5 rocket before the end of the year. For those interested, Go Space Watch, John Thatcher, is giving a talk on the James Webb Space Telescope on the 18th of August at 19:30. However, they're charging a price of £3 to view that on Zoom. And this is the telescope undergoing its tests. The test of having completed it, the plan is to have it complete by the 31st of October for final launch, but the exact date that it launched depends on other aspects of what the ESA has in terms of flights. The Ariane 5 has previously had some capsule failures, although the missions have been successful, and it was grounded since August up until the 30th of July, where they did another launch with 2 communication satellites, and everything went well. So it's looking good moving forward. When this is launched, it's going to go into the Lagrange point 2, which is the gravitationally stable point in space, about 930,000 miles from the planet. And the observatory will feature a 21.3 foot wide primary mirror and a deployable sunshade the size of a tennis court. And it will then observe the cosmos in infrared light. It will study the universe's oldest stars and galaxies and hunt for signs of life in the atmospheres of alien planets, among many other tasks. So that is something else to watch and look forward to. The next couple of items you've probably seen quite a lot of on the news. On the 11th of July, I put billionaire Richard Branson and 5 other crew members briefly launched into space for the first fully crewed spaceflight of Virgin Galactic's Spaceship 2 spaceplane. And that's the launch. That's them. I did in the 6.2 thousand miles above Earth. They did 4 minutes at low gravity. Everyone says no gravity, but there actually is a certain amount of gravity at low gravity before coming down and spending a 10-minute flight. And this is it coming into land. That was followed by Jeff Bezos, again, billionaire founder of the spaceflight company Blue Origin, launched into suborbital space with 3 other people on the first crewed mission of the company's New Shepard vehicle. It had Jeff Bezos on board with his brother Mark Bezos, an 18-year-old Oliver Damon, and an 82-year-old Wally Funk. Now, it's interesting, Wally Funk was what was called the Mercury, one of the Mercury 13, who were the women who trained as astronauts, but were not allowed to go into space. And this was her first opportunity of going into space. She was quite an experienced aviator. Oliver Damon is interesting because if you remember, there was an auction, and the anonymous person who won the auction and paid $28 million had something else on, and unfortunately couldn't take the trip. And he was given a later trip to take, and the person who paid the second highest amount was given the flight. He then offered it to his son. So that's how Oliver Damon got in, and he's now the youngest astronaut, beating the Russian previous youngest to go to space. And that, the booster landed successfully and the capsule landed successfully. Now, on the same date, the 20th of July, the FAA changed the rules for commercial astronauts' wings. They announced a major change to its commercial space astronaut wings program, which was launched in 2004. To be eligible to earn the wings, commercial launch crew members had to meet specific requirements for flight crew qualifications and training, and fly above a 50-mile, 80-kilometer altitude on an FAA licensed or permitted vehicle. Now, effective of the 20th of July, they've added the following criteria. With the new change, those flying on a commercial space missions must also demonstrate activities during flight that are essential to public safety or contribute to human space flight safety. This has put into doubt whether Jeff Bezos' flight team will actually get the commercial astronaut wings. And in addition, the FAA has also added that it can award honorary commercial space astronaut wings to individuals who demonstrate extraordinary contribution or beneficial service to the commercial human spaceflight industry. The FAA adds that these individuals receiving an honorary award may not be required to satisfy all eligibility requirements. That includes all the training aspects that the others need to do. However, they had one final statement: the award can be granted posthumously, which I thought was food for thought if anyone's actually volunteering to go on one of these missions. Now, after Jeff Bezos' flight, he then considered that he wanted to reiterate that he wants a NASA Artemis moon lander contract, and stressed that it's willing to put a lot of its own money, several $1 billion, into development and testing costs if it is selected. This was in the form of an open letter from Jeff Bezos to NASA. It came 3 months after Blue Origin-led national team, the Dynetics, lost out in the final round of the competition to SpaceX, which won a contract valued at $2.9 billion to develop its Starship spacecraft as the Artemis human landing system. And that's Jeff Bezos's Blue Origin proposal for the lander system. There was no response as yet I could identify from NASA to see whether they're considering it. The Hubble Space Telescope made a computer glitch. On the 17th of July, NASA returned the Hubble Space Telescope to full science observations after it halted suddenly on the 13th of June. After analysis, the findings pointed to the power control unit as the possible cause of the failure. And over a 2-week period, the NASA team proceeded carefully and systematically to review, update, and vet the procedures to switch to backup hardware, testing them on a high-fidelity simulator and holding a formal review of the proposed plan. And on the 15th of July, the plan switched to the backup side of the science instrument and command and data handling unit, which contains the backup power control unit, was made. And that shows the Hubble Space Telescope, which was launched in 1990 from the space shuttle. And it's been there in space that amount of time. It's not the first time that it's had problems with that particular unit that was changed over. In 2009, the space shuttle sent up a servicing team, which coincided with a similar problem, and astronauts actually changed out the unit completely, which was intended to give it a longer life and also give it the ability to make such changes as they made over the last few weeks. Now, NASA and the Department of Energy are funding 3 nuclear thermal space propulsion proposals for reactors that could become part of a nuclear thermal propulsion system, a next generation technology that could make the exploration of deep space faster and more efficient. For example, a spacecraft powered by nuclear thermal rocket could potentially get to Mars in just 3 to 4 months. Experts say about half the time required to using traditional chemical rockets. And the newly announced contracts will be awarded through the Idaho National Laboratory, the DOE, or Department of Energy Site for Nuclear Energy Research, And each contract is worth up to 5 million, and the money will fund 12 months of development work, which will culminate in the production of a reactor design concept. And the INL will review the concepts, then provide recommendations to NASA about how to proceed. And these are the 3 prime contracts. There's the Virginia-based BWX Technologies, in conjunction with Lockheed Martin, General Atomics Electromagnetic Systems with X Energy and Aerojet, and Seattle-based ultra-safe nuclear technologies. Got various partners there, including Blue Origin. And that's their proposed artist conception of a spacecraft powered by nuclear thermal propulsion. It's not the first time that nuclear energy has been used, because nuclear technology has been used before that uses the heat generated by the radioactive decay of plutonium-238, converting it to electricity that powers scientific instruments and other equipment. And it is currently helping robots such as NASA's Curiosity and Perseverance rovers on Mars, the Cassini Saturn probe, and the twin Voyager craft in doing their pioneering work. The propulsion version is slightly different, and that would transfer heat generated by a nuclear reactor to a liquid propellant such as hydrogen, which would then transition to the gas phase and expand and be funneled through a nozzle, creating thrust. It gives twice the propellant efficiency of traditional chemical rockets, and that would minimize the time to Mars, as we've also said. Nuclear reactors could also help humanity set up on other worlds after they get there. For example, NASA is also working on a fission power system for use on the Moon and Mars. German X-ray space telescope eROSITA. The German-built space telescope is creating the most detailed map of black holes and neutron stars across our universe, revealing more than 3 million newfound objects in less than 2 years. Launched in 2009 and called eROSITA, it is the first space-based X-ray telescope capable of imaging the entire sky. That's the Russian-German space probe, Spectrum Rontgen Gamma, and that's the actual eROSITA. 7 X-ray eyes, each of which combines a mirror module with 54 nested mirror shells and an X-ray camera. And it's looking for black holes and other aspects of space which have sort of not been seen before. It has already led to interesting discoveries, including a giant X-ray bubbles emanating from the center of the Milky Way. With its first public science release, it's poised to shed light on some long-standing cosmological mysteries, including the distribution of the elusive dark energy in the universe. And that's the latest sort of information that's come from the X-ray. You can see there, each bright spot in this image, the first all-sky image is a black hole or a neutron star. Ten times more asteroids hit Earth than previously thought. This is an interesting one, and I'm sure there'll be some follow-up discussions on this. Tiny bubbles of vaporized rock called spherules in the bedrock today suggest that ancient Earth was frequently battered by giant asteroids. The results of a new research study presented at the Goldschmidt Geochemistry Virtual Conference in July indicates that asteroids like the size of the one that wiped out the dinosaurs or bigger hit the ancient Earth more often than previously thought. And this is where you see asteroids impacts created infernal conditions on the young Earth. Now, what they're saying is that they've checked the amount of spherules in layers on the Earth, and that gives rise to there must have been more asteroids than what the current theory is in terms of the number of hits that have been recorded or understood to have been recorded. And the bigger the asteroid, the deeper the layer of spherules. And they're looking at a new method to model the amount of impact these asteroids have had, because they're saying that it would have reduced the amount of oxygen and would have delayed the development of the young Earth as it was then. They're also looking at, there was the Jupiter as a shield concept, which was put forward in 1994 by George Wetherell, a planetary scientist at the Carnegie Institution, who died in 2006. And his theory that Jupiter prevented a lot of the impacts from asteroids, they're now saying that wasn't quite true. It was Jupiter and Saturn reduced some of it, but Jupiter also enabled a lot more asteroids to come onto the Earth. If asteroids came in between Jupiter and Saturn, they got collected within their area. But if they came from outside that area, they got thrown in towards the Earth. And therefore, they're saying that probably caused more asteroid impacts than what was previously thought as well. But that, I'm sure that's going to be open to discussion by many other experts. And what they're saying is a lot of the crater impacts like that, some of the big ones can still be seen, but the weather and geological activity on Earth has removed a lot of the indications of previous asteroid impacts. You see, that's quite a big one. And that's all. Thank you very much.
Okay, Stuart, thank you very much for that. I'll tell you, whenever I see that image of that crater there, that last one you shown, that's the one in Arizona, isn't it? How lucky it was it didn't hit that visitor center. Sorry. Right. I'm just making up for the loss of Andrew's jokes we used to get years ago. Okay, so we'll move on now with the little bit of the More Sky at Night and the Perseids from Mick. Are you there, Mick?
Yes, indeed.
Just turn your camera mic off there, Stuart, please.
Oh, it's not going off.
We got you, Mick. That looks good.
Yeah. What's happening here? Righty-ho. Good evening all and welcome to the August edition of Sigma's Murray Sky at Night. So the darker nights are now creeping in, as you've probably noticed, and it's still not going to be proper astro dark until the 14th of August. Don't get too excited that night because it's only going to be astro dark for a whole 35 minutes or thereabouts. So I won't be covering any deep space objects until next month. However, there will be increasing chances for observing from now on as we head into the winter months. But as usual, I'll start with the planets. So I've got it set here to tonight, this evening, just to show you where the inner planets are. So Mercury was at superior conjunction on the far side of the Sun back on the 1st, and it's just creeping out now. If I put the atmosphere on, you'll see, absolutely no chance of spotting them at the minute. Just lost in the sunlight. Venus is in Virgo, too low to be readily visible, except early in the evening twilight. Mars is in Leo, initially close to Regulus, as you can see here, but moving eastwards towards Virgo, and that's very low in the sky as well, so quite hard to spot these. If I go to, right, the 20th, and I think I'm at 2300. So Jupiter, I went to the 20th here just as an example because you'll be able to see over the 20th, 21st, 22nd, the moon passing by. But Saturn and Jupiter are certainly, you can certainly spot them after dark. At the minute, they're quite low and quite difficult to photograph. I've tried it myself, but if you've got some better optics than me or a telescope on them, you probably fare a bit better. So as I say, Jupiter and Capricorn. Jupiter's coming into opposition on the 20th of August. Magnitude -2.8 to -2.9. And Saturn's in Capricorn. and that came into opposition on the 2nd of August. If I now go to the 27th, oh, wrong. 28th, and east, Uranus is in Aries, magnitude of 5.8 to 5.7, so you should be able to find that. And you can see the moon passing by it over those two nights, 27th, 28th, that's at midnight, I've set that to. Neptune is in Aquarius. If I head to the southeast, go to the 23rd. Now, Neptune, it is there, but it's probably going to be a bit harder to find. So I tried finding it already. Yeah, that's at a magnitude 7.9, so that should be observable with a telescope as well. And that heads into opposition on the 14th September. So due to the ongoing early sunrises still and late sunsets, there's not that much to see of note, but we do have a meteor shower this month, one of the best meteor showers of the year. Up in the northeast, it peaks on the 12th of August. So if we go to the 12th to 23, let's get some. We'll do some letters. And, oh, wrong way. Some constellation lines and names on for you. And to the northeast. And so the Perseid meteor shower, to find it, well, I'm pretty sure we'll know where Cassiopeia is. If we come down the left-hand side of the W towards Perseus, this is going to be the radiant area here. So you look anywhere, obviously, away from that, and you should see some meteors. So every year from around the 16th of July to the 24th of August, our planet crosses the orbital path of comet Swift-Tuttle, the parent of the Perseid meteor shower. Debris from this comet litters the comet's orbit, but we don't really get into the thick of the comet rubble until after the first week of August. The bits and pieces of the comet Swift-Tuttle slam into the Earth's upper atmosphere at some 130,000 miles an hour, lighting up the night with fast-moving Perseid meteors. This year, as I mentioned, the peak falls on the night of the 12th, going into before dawn of the 13th, which is just after a new moon. But the thin waxing crescent moon is going to set at 22:33 from our location, which is about an hour and a half after sunset and just before the showers peak. So conditions are very favourable for this year. I suppose any time after 10:30, 11 o'clock sort of time should be pretty good. At the peak, they can be up to apparently 100 per hour. I've seen quite a lot, but I haven't seen that many per hour. But it's certainly worth looking out for. It's normally good viewing, as they can throw out a few surprises, or they're fast, and many of the brighter ones leave persistent trains. And some bright fireballs also occur during this shower, so it's well worth looking out for. I think Pete will mention something to do with that for viewing it. That's me for this month, Pete. So I'll hand back to yourself. I'll stop sharing.
Okay, Mick, thanks very much. Yep, to say with the Perseids, I've been talking to Mick and others, and we sort of think about we can meet up and actually get together for this. Could I just have a show of hands if only people would be interested in meeting up to see this together? It wouldn't be a late night because I'm back at work on the 12th, believe it or not, but if anyone wants to click their hands, if they would be happy, if they want to meet up on that night. No one. Okay, well, what I'm going to do is I'll talk to Mick to see wherever the best place would be. And we have got hands up, have we? Okay, yeah, we have got a few hands up. That's good. So as I say, no point organising this if we don't want to try and get together to meet up to do this. So say what we could do early evening is like a binocular object evening, before it gets really dark. We can show you some of the brighter, sort of binocular object stuff, because it's still going to be around about 10 o'clock before it gets properly dark. But we can do a few things prior to that. What I was thinking, I'll talk to Mick and I'll talk to Rich as well about where we'll hold this. Kevin Stock said he would come along, but he's in Orkney. Well, you'll probably have a better show up there than we'll have down here, Kevin. To say, I'll talk to Mick about where we're going to do this, because as you see there, it's very, it's quite low to the northeast. So we really want a good north to northeast sort of horizon. So maybe somewhere down by the coast would probably be better to start with. Seems it's going to be earlier on in the evening. But don't forget to look out for it up, from now up until then. It's always better to see see any meteor shower as you're heading into them rather than heading out of the cloud. If you imagine it's like sort of snow, if you're driving into snow, you get all that passing over your windscreen. It's the same effect as if you're heading into the cloud of debris into a meteor shower. If you're heading away from the snow, if you look at the back window, it doesn't look half as impressive. But leave that with us. I'll talk to Mick over the next couple of days, and I'll get an email out to where we'll meet. And then obviously, because we've got out of practice of doing this now, we really have. I'll send out a go, no go email on the night of the evening of the 12th, at least an hour before we're sort of thinking of going. Okay, so keep an eye on your inbox if you're thinking of coming along. Right. Now a bit of news from me is the club telescopes. I've now got it's in the newsletter anyway, but now is the time to get hiring them if you haven't got a telescope yourself. Let's say we charge just £5, for the hire. That can be waived if, obviously I know a lot of people are having difficulties with this ongoing situation we've had. But if you want to hire one of the telescopes, please do. The Dobsonian is so simple to use. Don't be afraid to come and get it. As I say, it's so simple. Just put it down. There's two pieces and the eyepieces, and away you go, you're viewing. Okay. The Helios refractor, that's a little bit more complicated because it's on an equatorial mount. If you've never used an equatorial mount before, don't be afraid of it. When you pick it up, I will show you how to set it up and how to use it, and you'll get the best viewing that way. Okay. And I've also got an instruction manual that I've made up, which will be in the equipment box that you can refer to anyway. All right. As I say, normally £5 charge for that per month. If you don't get to use it because of bad weather, we'll refund the £5. And I say, if anyone's having difficulties, or if you're unemployed or you're a student, we can waive that fee. So don't panic. I'm really saying this because I've got them both in my observatory at the minute, and I know I need a bit of space. No, but if you want to hire one, just let me know. Return to physical meetings at Lambride. Kevin is now in contact with Willie at Lambride. There's an awful lot we've got to go through before we can get back there. Next month is online anyway, so that's already been organised. Let's say he's going to be in part with him with the people from Orkney are going to be joining us. As I say, we have a good showing of people. I mean, tonight we've had over 40 viewers on here tonight, which is spectacular for this time of year with people on holiday and everything like that. So we're hoping, get this, to get that one going and they get a lot of people coming in. But as I say, the hall, yes, they are looking at reopening and starting taking bookings again. But as I say, we will probably have to use the big hall, and whether it's available, and there's an awful lot of rules and regulations we'll have to go through as a committee before we say yes, it's safe to do so. But leave that with us and we will see what we can do. As I say, next month is online anyway. The BAA summer meeting. I've been in contact with Hazel from the BAA. As I say, the dates for that now is set for Friday the 9th and Saturday the 10th of September 2022. So remember, we were meant to be having it last year, but with all this hoo-ha, it hasn't happened. So a 2-day event going to be held at the Moray College, but I'll send more out about that as time goes on. Obviously, I will be going out for people, for volunteers to help out on the 2 days, the Friday night and Saturday. So those of you who volunteered previously, I've still got all your details. I'll be contacting you in the next few months to see if you're still interested in helping out. It won't be anything arduous. It's just basically welcoming people, giving them the badge, and sort of guiding them to the hall. Next thing is just to say, Sigma on YouTube. Don't forget, all our previous meetings are on YouTube for members. Then 6 months later, they go live to the public. This one is streaming live as we talk. And I'll send the link out to that later on. I did forget to pause it, so if you do watch it again, just skip forward through the break because you've got 10 minutes of music and nothing much else. As I say, later on, after this, we'll be having a Zoom gathering. I think Mick has already put the link into the chat. Yes, he has. So once when we finished here, if you just click that link there, that should take you straight through to the waiting room for the the member, well, for the Sigma gathering. Everybody's welcome. And if you've got any new members or anything like that, click the link, come along. We'll have a chat. We'll have a dram maybe, and we'll just see this and sort of see the night out with a bit of fun. Yeah, don't forget it might be worthwhile just making a note of that meeting pass, the meeting ID and password there. There has been a couple of issues with getting onto Zoom tonight to say there has been an update. So if there's any issues, you can just join by using the ID and password. Don't forget, if you've got anything from me, anything you're interested in, or you honestly think we can be doing a bit better, or just want to say thanks for everything, just ping me a mail, email. And let's say the next meeting is the GMFL, the George Fraser Memorial Lecture. For any new members, George Fraser was a astrophysicist born in Birkhead, and we try and run this every 2 years just to keep his memory alive. We are being joined by one of his colleagues from down south in Leicester, from the Space Centre in Leicester, and to actually do the introduction of Professor Charles Cockle. As I said before, Charles's last talk 2 years ago was absolutely fantastic. He's a brilliant speaker. Please do come along. And say I've sent out the link and everything to the YouTube in the newsletter. If you think of anyone who might be interested in come along, please send them the link. Everyone can join in on the night then. Okay. Or if you've got anywhere you want to post it, I can get you a PDF version sent over as well, something like that. Okay. So, okay, and with that, I want to thank everyone for tonight. Mick, you for being the co-host in the back. Rich, I would have said, but he had trouble getting on. Sorry, Mick, and also for your Sky and Night there. Chris for handling the Q&A so perfectly. Stuart for your space news, and of course David, our speaker for tonight. Once again, a fantastic talk from you, David, and I'm sure it won't be long until we're asking you back once again. Okay. So with that, everyone stay safe, and just remember, keep looking up, and I'll see you in a few minutes in the chat. Good night, everybody.